In the previous two videos, we set up three different MCC configurations, this time with MCC Melody, and we have three different MPLAB project configurations, the Polled Printf, DV runtime, and data streamer. So we're going to be building these now, actually making sure that these run and work on hardware. And this will be using MCC Melody example components, and so it'll be a good way to kind of get a sense of how those work and how you can quickly use those to build up certain functionality. Okay, let's go. So Ctrl Shift P, MPLAB, MCC, and launch. And here you can see that we have all three of these: Polled, Printf, data streamer, and DV runtime. So we start with the Polled Printf version. Okay, so the project opens. We can make some room. And these to-dos here with the example component haven't actually been checked off. Well, we haven't done many of them, but anyway, we did add an I2C host, select a PLAB connected to the I2C client. So we can see with this device that there only is one I2C on it. These don't change as you add to your project, they're just how much is on the device. And if we go to our connected tool, pinouts for all Curiosity Nanos. Okay, Q43. And you can see I2C here. This is in the context of the Curiosity Nano by itself and in the context of the Explorer. So obviously the pinouts here are the same, RB2 for serial data and RB1 for serial clock. RB2 for serial data, RB1 for serial clock. So I2C host, just naming it, rename custom name, PLAB software settings, interrupts no. So looking at the PLAB, we will use Polled version here. Select pins, we just did that. Add component delay driver, that's been done. Select LED pin as output. LED is RF3, that's this LED here. And you can see it's noted there as well. This is useful because sometimes the LED is not brought out on another pin as well. RF3. RF3. Okay. So that configuration is done, and notice that if we change the visualization from printf to data streamer, that this doesn't change here, but when we change from data streamer to DV runtime, here the visualization changes in terms of the configuration instructions. So let's go through these instructions quickly. So remove data streamer. Yeah, well, we're just doing the printf now. Add component UART, we've done that. PLAB selector, so UART is 1, 3, or 5, so we can do that. And RF0. RF0 is TX, RF1 is RX. RF0 is TX, RF1 is RX. So yes, TX. So interrupt settings no, which is the default, so we shouldn't have to do anything there, and redirect to printf, yes, and baud rate 115. So baud rate 115, redirect to printf, and interrupt driven no, which was the default. Okay, pin grid view, select GPIO pin output, rename as Debug IO. So Debug IO RB4, you can see it's also connected up there to the switch. So RB4 pins, RB4 Debug IO. Okay, so that is our configuration. Code generation. Okay, so we're going to get some examples here, just examples, I2C Host example, copy paste the snippet. So we're going to generate code, come in here to our Polled Printf, MCC generated files. We can see the output generated now. You can see these files generated 2:53, it's that time now, and I2C Host, and I like to copy also with the overview because you can see it's the proximity sensor Polled Printf, so we get some information of exactly what this is. Later you might start to use pieces of the example as you build up a larger application, in which case you just take the bits that you're interested in. Okay, just checking what is there anything to do's here. So notice we said Polled mode, we have a wait counter checking if I2C Host is busy. While it's not busy and the wait counter, then it's going to look at some tasks. So polling the tasks routine, and Ctrl, you can see that this is defined in the interface, and you'll see that that won't be there when we have interrupts enabled. Okay, save, Ctrl-Shift-P, clean and build, printf. That looks good. So now we come to our project, and you see that there's, for each configuration, there's a start debugging. So we can do that. Choose our board. So we can create a launch.json file at the project level as well. Okay, it is going to start debugging, so we don't need to do that, but we, okay, so it didn't need to do that now. Data visualizer, but that is the other option. So we're going to add debug IO as raw data on the plot. We're going to, this is 115/200, we add it as text in the terminal. We start running our project, and we can see how proximity is working. Okay, so first project config down. We have proved that this works, and let's go on in the next one and look at the data streamer.